Today's video is about the difference between inheritance and polymorphism. Hello, I'm James Helfrich. Some new programmers, especially new to object-oriented programming, use the term inheritance and polymorphism interchangeably, but they actually are quite different. This video will explain the underlying mechanisms for how a computer will implement polymorphism, as well as describe the differences between the two. All right, let's start with inheritance. Inheritance is when one class is based on another class. So for an example, I'm going to have a class diagram with a class called base. So in C++, I'm going to say class base, open, close curly braces, semicolon, there's nothing there. I'm going to have a private attribute called attribute1, which is an integer. So I'm going to say private colon int attribute1, and I'm going to have a private method called method1. Now notice at this point in time, I have absolutely no inheritance or polymorphism going on. It's just a regular class, a particularly useless class, but a class nonetheless. I'm also going to have a class called derived, which is going to have a private attribute called attribute A, and I'll have a private method called method A. Once again, kind of useless classes. These are two standalone classes. In my base class, I'm going to have a protected attribute called attribute2, which happens to be a bool, and a protected method called method2, which returns void. Now, once again, at this point in time, I have no inheritance going on here. Private means that only methods within my class can access attribute1 and method1, and protected means only methods within my own class can access attribute2 and method2, but also derived classes can. But at this point in time, we have no derived classes. Now I'm going to change things a bit. I'm going to make derived inherit off of base, and we indicate that in the class diagram with a triangle. In C++, I go class derived colon public base. And now I'm derived off of base. At this point in time, derived now has access to base's protected attributes and protected methods. So I indicate that in the class diagram with a slash attribute2, which is Boolean. In other words, derived can now access that attribute from base, as well as a slash method2 from base class. Now, we don't actually have to put the inherited attributes from the base class, but we can if we choose. Now let's see how this works when we run this code in the debugger. Okay, so we'll start by creating a base class. Now this base class is going to have two attributes and two methods, just like the slides before, and it will not be polymorphic. Let's take a look at how that works. Okay, so now I finished my base class. I have two attributes, attribute1 and attribute2. I have two methods, method1 and method2. Now all I have to do is create a constructor in order to initialize my variables, and I'll be ready to use this class. Now I'm going to create a variable. I'm going to call it B for base. We're going to break in the debugger and take a look at the attributes and the methods associated with this class. Now in the debugger, notice I only see two attributes, attribute1 and attribute2. I don't see any methods. And that's what we expect because there's no virtual functions and this is non-polymorphic. So now my next step is to create a derived class. Now initially this derived class will not actually derive off base, but I'm going to call it derived initially. Now, just like before, I'm going to create a variable called D, which is type derived. Now, there's no inheritance going on here, so when I break into the debugger, I expect to see only derived member variables, which should be just attribute A. I'm not going to even see a method. So base is unchanged, and D just has a single variable. That's what I expect. Now, the next step is I'm going to make derived actually derived off base. So I'm going to say colon public derived. And when I do this, it's going to change everything in the debugger. So I'm going to break into the debugger now. And what am I going to see? Well, base is going to be unchanged. So sure enough, I have two attributes. But now derived has itself as well as base's attributes. Therefore, I have inheritance here. Not yet polymorphism, but inheritance. Okay, now let's talk about virtual functions. At this point in time, we have inheritance, but we don't have any virtual functions. We don't have any polymorphism. Now in the class diagram, I can indicate a method is virtual by making it italic. So I'm going to gray out that method2, and now I'm going to make it italic. And how do I implement this in C++? Well, first of all, I have to take my method2, and I have to make it virtual void method2. And now that method is virtual. Let's see how that works in the debugger. First thing I'm going to do is I'm going to go up to the base class, and I'm going to make one of the methods virtual. And let's see how that impacts our code. Okay, so in the debugger, when I expand base, we'll notice I have this new thing called virtual function pointer table that has one entry, and that's going to be for my one virtual function. That's cool. Now when I expand my derived class, notice the base class also has that virtual function table. This means this function is virtual. In other words, that variable is attached to the object. It's not just a standalone method. Okay, so now I'm going to add another virtual keyword to method 1. I've got to spell it right, of course. And now I'm going to have two virtual methods. Both method 1 and method 2 will be virtual. When I step into the debugger, base now has two entries in the vtable, no longer one, and derived through base does as well. So I have my two virtual functions. Now, just for kicks, I'm going to go back into my derived class, and I'm going to make my own private version of method 2. It's going to be basically the same thing, but it's going to have a different entry in the vtable. So now when I break into the debugger, for base, notice how base is method 1 and method 2, but in derived, I'm going to have base is method 1 and derived method 2. In other words, derived is going to have a different version of method 2 than base, and that's what vtables allow us to do. Now, just because I have a virtual function in a derived class does not mean I have polymorphism. To indicate how this works, first of all, we'll do non-polymorphic. I'm going to have base B and derived D, and so these are going to be two standalone methods. I'm just going to have an inheritance here, and then I'm going to have base B copy D. Now, what's going to happen is I'm going to take the attributes from the derived class, and I'm going to copy them into the base class. The result, bcopy, is not going to be of type derived, but rather it's going to be of type based. So in other words, I forget everything about the derived that was unique about it, including this extra attribute or any other implementations. In the polymorphic example, I'm going to point bcopy to the base. And notice how in my polymorphic example, I can decide whether I'm base or derived at runtime. I don't have to do it at compile time. And now, what is the data type of bcopy? Well, it could be a pointer to a base, or it could be a pointer to derived. We don't know at compile time, but we do know at runtime. And so if I break into the debugger, I will notice that p copy might just be a derived type. Now, this is especially obvious when I pass an object as a parameter to a function. If I do a pass by value, then I'm going to make a copy of my value, and which means it's no longer going to be the derived class. It will always be the type specified by the copy. And pass by value makes this non-polymorphic. However, if I pass by reference or pass by pointer, then it is polymorphic, and I retain its polymorphic nature. Let's have a demo to take a look at how this works. Now, my first step is going to be to create a copy constructor for my base class so I can correctly copy the attributes over. So when I break into debugger, B is unchanged. It still has my virtual function pointer. Now, but bcopy is going to look exactly like base, and bcopy derived is also going to look exactly like base. In other words, bcopy derived is not of type derived anymore. It's of type base. Now, this will all change, of course, when I use a pointer. Now, I'm going to say base pointer p base, and I'm going to do the same thing with base pointer p derived. And even though it's a pointer to a base in both cases, the pointer is going to retain the nature of the variable. In other words, it's going to remember its polymorphic state. Now, when I break into the debugger, notice that p base is going to be of type base, but p derived, when I look at the vtable, I'm going to see that I have my derived method. I don't have my base one. I remember my identity, where p base is both going to be base for method 1 and method 2. Now, one final experiment. I'm going to create a function, and this function is going to take a base by value, by reference, and by pointer. And we're going to see how these are going to be represented very differently when we run it. Okay, so let's break into the debugger, and let's take a look at by value, by pointer, and by reference. Remember, in main, these were all my derived class. So by value, when I look at my vpointer, both the methods are the basis version. By reference, we're going to notice that Method 2 is the derived version. And by pointer, we're going to notice that method 2 is also the derived version. Thus, I need to pass an object by reference or by pointer if I want to retain its polymorphic nature. And if I pass it by value, then I'm going to slice off any specific functionality associated with a derived class. Okay, so we can see that polymorphism can only happen when I either have pointers or I have by reference. And this is because pointers and by reference are late binding constructs. We can learn more about early and late binding in the early and late binding section of the polymorphism chapter of the software design textbook.